Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera and good day. It is a pleasure to welcome respected speakers, delegates, and participants to the International Conference on Earth Resources, Icer 2020, organized by University Teknologi Petronas Geoscience Department and co-organized by Icer Lab Asia, Universitas Negeri Gorontalo, Indonesia, and University Teknologi Petronas Shale Gas Research Group. Icer 2020, with the theme Geosciences for Sustainable Future, will address main issues related to the sustainable exploration, exploitation, and production of Earth resources for conventional and unconventional resources. We have three prominent plenary speakers for you, with topics centered on knowledge, roles and challenges, as well as solution work for sustainable development of Earth resources. Icer 2020 have been classified into 5 tracks of interest include sustainable oil and gas exploration and production, sustainable exploitation of minerals and rocks, unconventional oil and gas resources, groundwater and geothermal energy for sustainable future, emerging technology and geohazard forecasting. On behalf of Icer 2020, we would like to extend our sincere gratitude and appreciation to Front Lab Asia, Universitas Negeri Gorontalo, Indonesia, and University Teknologi Petronas Shale Gas Research Group for your support as Icer 2020 co-organizer. We would like to thank our plenary speakers, Prof. Emeritus Datuk Dr. Ibrahim Komo, Principal Fellow, Institute for Environment and Development, Lestari, Universiti Kebangsaan Malaysia, Mr. Idris Ibrahim, Chief Executive Officer, Institute Teknologi Petroleum Petronas, INSTEP, Dr. Chris Morley, Senior Geophysicist, PTT Exploration and Production Public Company Limited, PTTEP, and all presenters and delegates from all around the world. I would like also to take this opportunity to thank Icer 2020 Organizing Committee for working hard to make this conference become reality. Among others, you will be able to explore the various features available in the Virtual ESCON 2020, include virtual exhibition booth, and interact with exhibitors, resource gallery where you can download all the conference materials, virtual tour so you can get to know UTP better, live support where you can feel free to ask or seek clarification about the conference, and also gamification feature which allow you to gain more points. I hope that in this conference, you will be able to forge connection, strengthen in network, and gain benefits from the conference. Be a part of one of the largest congress in the world and have an enriching time in ESCON 2020.
Bismillahirrahmanirrahim and good afternoon. Assalamualaikum. Welcome to Icer 2021. My name is Nur Azahar Ibrahim. I am from University Teknologi Petronas and I will be the session chair to kick off this technical session for this afternoon. We will have 6 paper presentation for this session. Each papers was given 15 minutes to present their paper. We will follow by 5 minutes of a Q&A. I would encourage the audience to post the question in the chat box provided. Okay, without further ado, I would like to call our first presenter, Mr. Nafir Nebeho, supported by Siti Nur Fatia and Dr. Nur Halim, to present a paper titled Compaction History based on porosity, pressure, and temperature in relation to the Central Luconia province in Sarawak, Malaysia. Please play the video.
Very good day to the respected audience of Icer 2020. Today I would like to present my research paper entitled Compaction History based on Porosity, Pressure, and Temperature Relation Analysis, Central Luconia Province, Sarawak Basin, Malaysia. My name is Rafael. Together with me are Madam Siti Nur Fatia binti Jamaluddin, Dr. Abdul Halim Abdul Latif, and Dr. Maman Hermana Hussein. We are representing Department of Geosciences, University Teknologi Petronas, Malaysia. So here's the outline of my presentations today. I will start with introductions, then research problem, objectives, methodology, results and discussions, and lastly I will conclude. So Central Konya is located in Sarawak Basin, and it is surrounded by many provinces, as you can see in this figure. Stratigraphically, it is divided into cycles 1 to cycle 8. But for this project, I'll be focusing more into cycle 2 to cycle 6, which covers the clastics, lithology, and also the major carbonate platforms. In terms of the data, I use 5 2D seismic lines with 4 wells located adjacent to the seismic lines. So in terms of the hydrocarbon, Central Konya is a very prolific basin in terms of gas. It contributes about 60% of the total Malaysia gas reserve, about 65 trillion cubic feet. And it has been producing for about 30 years from the Miocene carbonate platforms. We know that in hydrocarbon explorations, also porosity plays a major role, but we cannot deny that compactions affects porosity reductions through time. So generally, I found that there's an issue in actually understanding the compaction history because there are so many factors involved, such as lithology, pressure, temperature, so on and so forth. Specifically for this province, according to Modern et al. 2013, there's a sediment thickness variations in the south, central, and also north of Central Konya, of Laconia province. So to analyze these problems, we need to come up with an idea of actually relate this analysis between 3 factors: porosity, pressure, and also temperature. So to achieve the main aim of investigating the compaction history, there are 3 sub-objectives that we need to achieve. First is to determine the sediment thickness of each cycles. Next, to analyze the porosity depth relations. And lastly, we want to correlate the porosity loss with the pressure and also temperature. So here's the methodology divided into 2 parts: seismic data and also well data. So for seismic data, the main output is the thickness map. And for the well data, the main output is the relationship between porosity with depth and also pressure and temperature analysis. For calculating the porosity, I'll be using density porosity and also neutron density porosity because sonic, it's not widely viable for mostly the wells that I have. So I did porosity calculations using density porosity and also neutron density porosity equations. So from the output of seismic and well data, I also integrate with the sea level fluctuations and also regional geology analysis. And lastly, I will synthesize those outputs from seismic and also well data. So first result is related to seismic well tie. So I did seismic well tie using FF6 well, correlate with the seismic 2D lines of R2. And the wavelet produced using analytical recurve method with central frequency of 35 Hertz. And I did a minor bulk shift, especially on the cycle boundary, which I already have as my marker to tie the well with the seismic trace that I have. Next, to do the horizon interpretation. So I did horizons interpretation for top and also mostly the top, of each cycle from cycle 2 to cycle 6, with main highlight of the carbonate platform. As you can see here is the major carbonate platforms, with also the clastics on top of these carbonate platforms within the cycle 4 and also cycle 5. From the interpreted horizons, then I did thickness map generation. So I did thickness map for each of the cycles. But the main highlight here is still the carbonates platforms. So I found that there are 2 mega platforms here with size over 16 kilometers times 21 kilometers with thickness up to 1 kilometer. So it's very huge carbonate platforms we can find in Central Konya. And then cycle 3 and also cycle 2, we can see that in cycle 3, the lithology is intercalations between limestone and claystone. But for cycle 2, it's mostly claystone. But the depth or the thickness of cycle 3 and cycle 2 is mostly the same, about 300 meters to 500 meters. And then I did a cross-plotting between porosity with depth. So for LH1 and also FF6 well, we can see that the porosity reduces from about 33% on the most top cycles, which is cycle 6, and reduced to 20, 17, and lastly 14% on cycle 2, which is the bottom cycles. For FF19 also, we can see that porosity reduces from 31% to 18%, but it only covers cycle 6 and also cycle 4 and 5 clastics. Lastly, for FF5E, the reductions we can see from cycle 6 to cycle 4 and 5 clastics, about 21% to 12%. However, for carbonates, because of the nature of the carbonates, which has more porosity compared to the clastics. The porosity increases from the cycle 4 and 5 clastics to become 23%. And then I did a cross-plotting between pressure and also depth. So according to Atnoy Lawyer 2011, upper pressure zone affects irregularity of porosity reduction with depth. So I draw a normal pressure line, as you can see here, and I found that LH1, FF19, and also FF5E, it has upper pressure zone at different depth locations. Next, also to cross-plot the temperature with depth. So according to Joachim Nadio 1998, they say that when the temperature reaches 80 degrees, there is a major role of diagenetic reactions, which include quartz cementation and also eelite precipitations. And as the result, it causes significant porosity reductions, which I will explain further in the coming slides. So based on those cross plots, so I will synthesize those results from porosity, temperature, and also pressure. So from the temperature log, or temperature figure, we can see that it reaches about 80 degrees Celsius at a depth of 2,600 and also 2,800 for the upper pressure zone. So when we correlate to the porosity, we can see that at depth range, the porosity reduces about 15% and drops drastically to about 8%. And below that depth range, we can see that the porosity also become more irregular, and that confirms the effect of overpressure and also the diagenetic reaction from the temperature. The same evidence we can find in FF19. So it reaches about 80 degrees Celsius at depth about 1,700, and the same depth with the overpressure zone. And we can see that on the porosity cross plot, the porosity also become more irregular because of the effect of overpressure and also temperature. FF5 is quite unique because at depth 1,000 meters, we can find that the pressure, there's a sudden increase of temperature, but sudden drop of pressure. However, the increase of the temperature, it doesn't exceed the 80 degrees cutoff. Hence, there is no sudden drop of porosity, as you can see in this figure. However, at the deeper part, which is about 1,700, we can see that there's a upper pressure zone, and that correlates to the irregularity of porosity at these locations. And when it goes deeper, there's the pressure become normal again, and we can see that the pressure at the porosity also reduction with that. It follows a normal trend. And last is the FF6. It reaches about 80 degrees, about 2,500 meters, and that's why the porosity also becomes more or less irregular with that. And lastly, we want to correlate with the sea level. So according to this sea level curve from Huck et al. And Myler et al., you can see that there is a global sea level increase in the middle Miocene, but in the early late Miocene, there's a sudden drop of sea level, and that actually causes calcifications of the carbonate that grows in the middle Miocene, and that induces secondary porosity, which we can see the evidence of increased porosity to 30% in FF6. As you can see here, the FF6 as carbonate platforms, the porosity is about 33 or 35%, but at the top, on top of the cycles, cycle 6, the porosity reduced to about 25%. And that increase of porosity, it is possible, it's because of the calcification process. So as a conclusion, we can see that the thickness map, cycle 6, the thicker clastic sedimentation, it induced the compaction within the order formation, and that's actually deposited from the clastic influx from Baram Delta. And we can see two carbonate platforms at the cycle 4 and 5. For porosity analysis, we can see that there's normal distributions, general distributions of porosity at the north, central, and west. But for the east, we can see the sudden drop of 21% of porosity from 33% at the rest of the area. For limestone, it's about 22%, while for cycle 3 and 2, it's about 16% of porosity. And lastly, we can also conclude that upper pressure zone affects irregularity of porosity reduction with depth, while diagenetic reactions causes significant porosity reductions. And lastly, sudden increase of porosity at the limestone, it's because of the calcification process that induces secondary porosity. So To conclude, this study had proved that compaction is not only related to porosity loss, but also changes in pressure and temperature and dependent on natural changes of sea level. So here are the key references that I used for this project. And we would like to thank Malaysia Petroleum Management MPM of Petronas for giving permissions to use the data for this study, and also to UTP Fundamental Research Grant with cost center of 015 MD0 059 for supporting this research project. And with that, I would like to end these presentations. Thank you.
Thank you, Mr. Raphael. A very good presentation indeed. I believe this is important for to explore more gas within Malaysian province of Sarawak, mostly in Central Luconia. Okay, we have one question to you with regards to the methodology that you use, that you infer as a so-called depend on the nature of the sea level changes. Could you share what evidence that you see from your data that indicates that sea level changes in the early to late Miocene influence the changes in the temperature and the pressure regime within your study area?
All right. Thank you so much for the great questions, Sanchinai. So yeah, for the evidence, actually we can see from the literature that I obtained, which is from the Fulterpe et al. 2011, that we can see there's a major sea level changes where in the early Miocene, yeah, in the early Miocene there is like a sudden drop of sea level, and when we correlate that with our well report, we can see that actually there's an evidence of castifications. So to verify these findings, we see through our the data set, which is our well, is in the FF6 well. So that FF6 well actually we can see there's a sudden increase of porosity because of that castifications. We know that castification is actually a process where the carbonate being exposed to the atmospheric conditions, and that actually enhance the secondary porosity, which creates the porosity becomes higher. And when we correlate that with our porosity will with that cross plot, we can see that the porosity even increases suddenly. So that's actually the evidence of how the sea level changes affects our porosity, pressure, and also temperature. Thank you.
Thank you, Mr. Raphael. So I believe that is the only question that is posed for you. So I would like to thank you for a fine presentation. Thank you again, Mr. Raphael.
Thank you, Jinai.
Okay,
Everyone.
let's move to the second presenters. We have a paper. We have a paper entitled "Sustainable." The evaluation of the basement morphology and the carbonate build-up in Central Luconia province from FTG data. The presenter is Siti Nur Fatia, supported by Mr. Jamaluddin and also Dr. Benjamin Sutter. Without further ado, please play the video.
Hi everyone, Assalamualaikum and very good day. I am Fatia from University Technology Petronas. So for today, my presentation will be on the evaluation of basement morphology and the carbonate build-ups in Central Luconia province based on my analysis of the FTG dataset. This will be the outline of my presentation, which I will cover a little bit on the study area, followed by the theoretical part of the FTG dataset, and then we'll straight away go into the how does the interpretation for the FTG gravity anomalies and aeromagnetic were done, and then I'll compare the depth profiles with the seismics and available exploration wells in the study area, and finally we will summarize and conclude this presentation. So the study area is located in Central Luconia province. This is an offshore province in off coast of Sarawak. It is dominated by prolific hydrocarbon reservoir within the Miocene limestones. In 2014, Bell Geospace had acquired a full transform gradiometry FTG gravity and aeromagnetic within the central to southwest Luconia province. So this is the study area coverage. The variation in density of the sediments in the subsurface of Luconia, which include the variations of siliciclastic sediments, and thick limestone provide a good penetration for the FTG, thus give a good high resolution data. How and why the FTG dataset is investigated within this province? First of all, the
Cik Uda, can you hear
inconsistency
me?
in the limestone build-up's orientation is pre-evaluated to reflect the basement topography. As we can see from this figure, the gray shadings are representing the carbonate build-ups. So we can see the size of the carbonate build-ups, the orientation of the carbonate build-ups are inconsistent. So it is pre-evaluated to reflect the structure underneath the sedimentary deposition. This remained inconclusive, so we try to investigate through the new set of FTG and aeromagnetic data. How FTG works? So this is the instrument, and we mounted this instrument on the aircraft, and then we fly over the study area. FTG is a multi-component gravity survey that measures the accelerations in the inlines and cross signals from the gravity gradient instruments. So this is the gravity gradient instruments that measure different tensor components. So the different tensor components are from the depth or Z components, the X component, horizontal, and the vertical components of Y. It is a full spectrum broadband gravity data, and each of the components we can generate another different few more tensors from then, and then the combination of these tensor provide a more accurate structural interpretation. Gravity data or FTG data is better than technically it is high resolution, higher signal to noise ratio, and it gives a high detectability, especially at the middle zone depth around 4 kilometer to 5 kilometer. At the same time, the acquisition of the aeromagnetic data was done during the acquisition of FTG. So this give an extra advantage on the data set, and then we utilize both data set. How do we do it for this study? So what we did is a process FTG data from Bell Geospace, what we received from them, and then we combine the air FTG and aeromagnetic. We do application of continuity and apparent susceptibility filters and do kriging smoothing to produce the maps and so on. After we do the QC and make sure the scales are specialized and identified, we differentiate the FTG into the depth components. So we select the depth components only because that is the most valuable for the geology. So in the depth component, we analyze the TZ, TZZ, TXZ, and TYZ. So from here, we identify the lineaments and measure the strikes and so on. At the same time, we also did the same for the aeromagnetic data, and then we just use the total magnetic intensity that reduced to the equator and its derivative. Uh, Before we start with all this, we did a simple or initial steps comparison by doing the zonation or classification based on the gravity and magnetic response from the FTG and from the conventional gravity and magnetic data. So this is the zonations in the offshore to near shore of Luconia province. Before we to avoid delay, let's go into the results straight away. So in the results, I am showing the FTG gravity anomalies maps for the TZZ and TZ component. So the TZZ is a higher frequency that provides shallow detection for the shallow section. In this, it covers a short wavelength, and the lineament analysis or structural analysis provide northwest to southeast and east northeast west southwest trend dominated in the shallower section. Based on the TZAC or low frequency long wavelength data, we can see the interpreted structural provide quite a number of directions, and mainly they are oriented in northwest southeast, northeast southwest, as well as quite a number of strong indication for east-west orientation. So this east-west orientation has not been seen in the shallower section. So there is something new or something different coming in the deeper section of the subsurface in Luconia province. As we go into the aeromagnetic anomalies, we did the same procedure as what we did in the gravity data. So based on the TMI total magnetic intensity that has been reduced to the equator, we can see the dominant structures are in east-west, similar to the TZ as we see previously, also in east-northeast, west-southwest direction. In their first derivative aeromagnetic map, what we can see, the dominant structures are mainly dominated within the east-west orientation. In these highlighted ovals and the rectangle, the red rectangle over here, we can see that there is improvement or segmentation in the structures within the southwest section of the study area. In here, we can see that it is all low aeromagnetic data, while over here we see the low magnetic data is actually uh, covered as well by a small section of high magnetic data. This is like an island showing different sections of the structure. So this might reflect the basement morphology because the aeromagnetic or magnetic data reflects or captures the crystalline basement, which is the granite or the metamorphic rock. And in this area, we can see that there is actually like looks like a folding over here. However, we could not see the same structure in the first derivative aeromagnetic data. We also do a comparison with the FTG depth profiles from section X to X prime with seismic line 1014. And this seismic line 1014 has limestone build-ups that is pointed by the orange arrow in C and D. And this orange arrow is actually represented by shallow or short wavelength uh, response from on the depth profile. So we can see that this is represented by the green color over here, and this is matched correctly with the top of carbonate in the seismic data. While the response from the long wavelength data in the depth profiles is at about depth 2,700 meter. This is represented by sediments in cycle 1 or cycle 2. So this is based on the interpretation. How do I know that it is cycle 1 and cycle 2? Because we have wells over here. So these wells is Lada Hitam 1 and F66 wells. The FTG data shows that wells F6 and Lada Hitam 1 were drilled on low density. So we can see the low density is over here. And then it's generally indicate a deepening or basinal shape structure. From the seismic line that crosses Lada Hitam 1 and F661 over here, this is line 90 crossing Lada Hitam, and line R2, the dotted line over here, crossing F6, we can see that both wells are actually drilled on elevated or uplifted structure. So we can see the surface underneath it is the structure underneath it showing morphology of an anticline. Same goes over here. However, the uplifted is usually showing high gravity, and basinal is showing low gravity. So this is low gravity area. So where does it come, the low gravity? The potential basement, let's look at the potential basement and cycle 1 sediments. And this is actually showing over here and over here that they are faulted blocks, and this faulted block has a large offset And the downthrown block is actually giving the response of the low gravity. So the gravity anomalies are showing the response from shallow, which is the top carbonate, to the deep subsurface. So we need to verify which one the response of the gravity is representing either the top carbonate or the deeper subsurface. So how do we do that? Is by differentiating in the TZZ map and TZ map as what we show just now. So in summary, the east-west structural trend that we see in the long wavelength gravity and in the aeromagnetic data appears only in the deep subsurface. It is interpreted to be related to the orientation of the basement in central Luconia because we have compared it with the structural map by Pubule et al. 2017 and Madon and Yamin et al. So this east-west structure has not been mapped yet. It is interpreted to be related to the basement of Luconia. So the airborne gravity analysis in central Luconia provides good quality and high resolution data due to variations in the sedimentation in Luconia. And the Miocene carbonate build-ups represented by the shallow subsurface or by the short wavelength of the gravity, which is the TZZ domain tensor. And they usually exhibit low gravity areas, exhibit small scale build-ups compared to the build-ups in the West Luconia, the southern part of it. A circular structure with depressional features are dominated usually by the low gravity anomaly in the central section. And finally, what we did is we try to classify the area into basement high, which is high gravity, high magnetic, and basement area B, which is the prospect area, which showing high gravity, low magnetic. And most of the zonations of area A and area B, they are mainly located next to each other or overlay with each other. So this is something that we need to further investigate in order for us to evaluate the prospect of new hydrocarbon new hydrocarbon drilling location, basically from the uh, unexplored limestone build-ups in Central Luconia. With that, I would like to acknowledge Petronas, MPM, and Bell Geospace for providing the data for this study and also for providing the technical help in this study. With that, I thank you and let's move to the Q&A section.
Okay, thank you very much, Fatia. Let's just see. We have one question to you. It's very interesting related to the industry.
Yeah, thank you.
The question have two parts. The first question is that using this data, same as any gravity, are you able to estimate the depth of basement in the low density contrast depression? Number one. Number two, how about the convincing estimation of the depth to basement on the structural high?
Okay. Thank you, Encik Nai, for the question. For the first question, yes, we are able to give a range for the basement, for the crustal structure in the low density contrast. It's just like quite a big range. We use the short wavelength and then the long wavelength. So we estimate the low value and the shallowest value and then the deepest value. So we have ranges. We don't have the exact number. For us to validate or for the second questions, to check if this is correct or not, and then we use the regional seismic. So if we are able to convert the regional seismic to that domain, and then it will be more convincing for us for the estimation of the crustal structure. So
Okay,
that's my answer.
Fatia. Thank you, Fatia. There is a good answer that I think the industry would like to hear from you.
All right.
Even that the enhance, because this study can enhance the understanding on the depth prediction to the depression, because it will
Correct.
influence in terms of the understanding on the direction of hydrocarbon pathway
Correct. Yes.
in
The
relation
flow.
to the accumulation of the hydrocarbon in the carbonate build-up in Heteroconia. Because as you point out, you have carbonate that is built up within the depression sedimentary. You
Correct.
also have the carbonate that built up on a structural high that is sitting
Yes.
on the whole older sediment. But
Yes.
we believe that the understanding on the basement in relation to where they are in terms of the build-up is very important to understand the architecture of the carbonate build-up itself. I
Yes.
think it is a very important study, could probably be further developed into the industry knowledge. Thank you, Fatia.
Thank you. Thank you, Encik Nai. Just a quick information. The study by Raphael just now for porosity, he also investigated the wells that covered in this FTG. So when we compare, it found out that the porosity values for cycle 2 carbonate in the area that have low gravity, low contrast gravity and density, they are located in the depressional structure or basinal structure. So this is something interesting to check out with the porosity and the permeability of the limestones in cycle 2.
Thank you,
So
Fatia.
yeah.
I can only take that answer because we are running short of time.
Yeah, I understand.
Thank
Right.
you.
Okay.
Okay,
Right.
can we move to the third presenter? We have a paper by Mr. Ghazi Sohail Imran, together supported by Dr. Numair Siddiq, Dr. Abdul Halim Latif, Yashir, and also Asgari, Abdul Salam, and Abdul Said Ali. The paper titled Reducing Uncertainties of Hydrocarbon Prediction through Seismic Inversion. Please play the video.
Hello and good day to you all. My name is Qazi Suhail Imran and I'm from University Technology Petronas, Malaysia. Today I'm going to present my research paper, Integrated Well Data and 3D Seismic Inversion Study for Reservoir Delineation and Description. This paper is being presented in International Conference on Earth Resources. So first of all, I would like to go through the presentation outline in which I will cover the introduction or the objective part and the study area in which I worked and the methodology, some results and discussions in which I integrated petrophysical analysis, deterministic and stochastic inversion, quality control steps, cross plots, and conclusion. Okay, so the introduction and objectives. As we know that describing and delineating a reservoir is very difficult, especially in an area which is offshore and having fine sands and several other issues like gas cloud issues. Because of the heterogeneity of the subsurfaces, it has always been very difficult to delineate reservoirs. So most often conventional techniques may fail because of the heterogeneity of the earth. So what we do is we normally integrate several techniques and do the quantitative interpretation to successfully delineate the reservoir. So drilling risk and associated uncertainties can also be minimized by this way. So one of the objectives for the study is to, of course, delineate the reservoirs and also, which in turn will minimize the drilling risk and associated uncertainties. So petrophysical technique and seismic inversion, stochastic and deterministic inversion have been used to integrate and to delineate the subsurface heterogeneity in the subsurface reservoir. So the study area lies in the pull-apart extension rift basin in offshore Malaysia. Geologically, it represents a layer cake, a simpler model. This basin is quite petroliferous and also mature and has witnessed extensive hydrocarbon exploration till now. H and I units, as you can see in the stratigraphic column here, are the Miocene age access source, whereas the ABD and E units of mid to upper Miocene age access reservoir. So here's my study area in the northeast Malay Basin. The methodology I use 3D seismic data and petrophysical evaluation, the well logs. and the geological facies are sent to the stratigraphic grid in stochastic inversion case, and also use the same data set for the deterministic inversion, which gave us the elastic properties, which later we cross-plot and analyze for the reservoir bodies description and delineation. I'm going to cover that in the next slides. So the main aspect of stochastic and deterministic inversion is that these compensate the missing frequencies by using the priori model or the background model, or also the perigram in case of stochastic inversion. And in this way, we delineate the reservoir and also even the thin beds up to 4 or 5 meter thickness. So results and discussion part. First of all, I carried out petrophysical analysis on several wells. Here you can see 2 of the wells I have shown here, where the volume of sand, silt, shale, is and also the water saturation, porosity, total and effective porosity were also calculated, as you can see here on the reservoir level 1440 meter, very good cross over, you can see here. And the fishes here, you can see the sand fishes are also here, and the water saturation is here very high, so it shows that it's a reservoir. On the same level on another well, and it's the same case here. So this was the petrophysical analysis, so used these inputted to the stochastic and deterministic conversion. So deterministic conversion shows the QC plots of low frequency model on this figure here on the well and 3D space, how these prevail in the 3D space. This is basically the background model for deterministic conversion. And here's the deterministic inversion results on the well and in the 3D space. It has delineated the reservoir well, but I will show you the deterministic results are for better. So the elastic properties for the grid, as we know that we first make a grid for the stochastic inversion, in which we basically populate the data, the elastic properties, for example, using several algorithms. In this case, acoustic impedance, you can see on several methodologies, several algorithms have been used, and the best one was had been chosen to populate these elastic properties in the reservoir grid. The stochastic inversion, the final output, and you can see the acoustic impedance realization, several of them in the 3D space and also in the cross section here. Density realization, BPVS realization, and how beautifully it has captured the layering and the subsurface features. Very important aspect was to quality control of all these realization. I showed them in well section window here, and the best one was chosen, which was following the acoustic impedance log very well. So and as you can see that about 2 to 3 meter thickness thin beds were also covered. So this one was one of the best realization was chosen for the reservoir body identification here. The impedance volume through the several wells here, the top D60 and E6, E7 pole was delineated as a reservoir body for this area using the impedance volume here. So an RMS amplitude and porosity maps were also generated. As you can see, the red is a low amplitude and the green one is a bit higher amplitude, may link to the fluid and porosity variation. Porosity varies from 15% to 22-23% in this area here, you can see. So in order to describe and discriminate between the lithology and fluid, we made the crosspots here, inverted data of the seismic and also well data, and here are the results shown. In the first one, we discriminated the lithology and fluid between the P impedance and also the BPVS. As you can see, oil sands, green dots, gas sands, red dots, brine sands, and shale. The B plot shows that the oil sands green dots have higher density and P impedance compared to gas and sand red dots. So the C1 shows cross plots between total porosity and P impedance shows good porosity distribution in the area. So this further enhanced our trust and that we have delineated successfully. The conclusion, the main hydrocarbon trap type is east-west elongated faulted features, compression and decline. So the petrophysical analysis shows that most of the lithologies are very fine heterogeneous sand silt reservoir and clay shale also present there. Parts of reservoir are below seismic resolution. Sand density was determined to 2.4 gram per cubic centimeter. Presets in seismic deterministic and stochastic conversion was used, which successfully delineated the sub-resolution reservoir bodies of 6 to 12 meter thickness. Like D60, E6, E8 between 1200 to 1800 meters milliseconds across the study area. Variation in P impedance realization suggests there's a presence of brine and oil sands in D group, whereas the brine and gas sands in E group mostly. This was confirmed, as I have shown through the plotting of the inversion data as well. The identified oil sands and gas sands in reservoir interval have 15% to 22% fair to good porosity distribution in the area. The quality of the results shows that the integration of these geological and geophysical approaches have delineated the reservoir body successfully. More well data and better resolution seismic can improve and enhance the results. That's all. Thank you so much for listening. These are the references, and thanks for being here. If you have any questions and or suggestions, please do let me know. Thank you and stay safe.
Thank you, Mr. Ghazi. A
You're
fine
welcome.
presentation paper on the specialized geophysics. Okay,
Thank you, sir.
you have two questions because you did mention about the tin beds. Can you use this study to evaluate hydrocarbon presence from tin beds, say less than 30 meters?
30 meters. Yes, of course. As I mentioned that this study was able to delineate around 5 meter to 10 meters thickness thin beds in Malay Basin.
So are they talking from the gross or is it from the net thickness?
Net, in fact.
From net?
Yeah.
Okay. So will that complement in terms of the quality? Will that be useful if even you don't have a high quality seismic in this area?
Well, of course, if we have the high quality seismic, of course, that will improve the result more.
But how about the area that without any good quality seismic?
I mean, this area?
Yeah.
Yeah.
Because most of the time that you're talking about so-called the area that will be explored in the tin beds, they are normally in the new frontier targets.
Yes.
For example, in Sarawak, in cycle 5, cycle 6 and above. So they are mostly kind of sheet sand.
Yes.
Do you think that they are useful?
Yeah, yes. I mean, if you integrate the quantitative techniques as I have done in this case, like the deterministic, stochastic, and also the rock physics, that can improve the results better because as we know that these quantitative interpretation is very successful even if the data quality is very bad. So if the data is good, of course you can have more better results, but the quantitative interpretation can help you even in worse areas.
Okay, that is another question because we talk about so-called the amount of data. Do you think that this type of inversion studies can be used in areas that have less well data to calibrate? If that's so, how effective?
Well, this is the issue with the inversion. Mostly, it needs a lot of wells. Not if not a lot, at least a dozen well would help. So, if the wells are not there, then I'm afraid the results will not be that good.
So in respect, you can say that when you talk about the area have high volume of data, where you use a lot of well data, meaning that a lot of well have been drilled. So the chances for us to find big new hydrocarbon pool might be compromised. So it will be very useful in the area when you are doing small pool exploration, what we call it the near field exploration,
That's right.
to support development and so on. So
That's
I
right.
think that it's very, very powerful tool to add more contingent resource within so-called a nearby discovery or
That's right.
being developed. Thank you, Ghazi. I
That's it.
think it's a very interesting paper. Look forward to see you. All the best.
Thank you.
Assalamualaikum, Ghazi.
Walaikum salam. Thank you so much. Thank
Okay,
you, everybody.
we will move to another presenter. The title of the paper is Discriminating Seismic Amplitude Pitfall by Low Saturation Gas Utilizing CSCM Technology. Will be presented by Ms. Nur Farhana Saleh, together with the co-author, Dr. Maman Hermana, Amatul Shafi, Abdul Basit. Please play the video.
Good day everyone, I'm Farhana and I'll be presenting a paper with the topic Discriminating Seismic Amplitude Pitfall of Low Saturation Gas Using CSEM Forward Modeling in K-Field Central Luconia. This is the presentation outline. First, in the introduction, I will talk about the seismic amplitude pitfall due to low saturation gas and the difference of gas behavior in shallow and deep subsurface. I will also talk about the geology and shallow gas in cave field and some introductory information about CSM technology. Next is the research objective, methodology, results and discussion. Finally, the 5 minutes of Q&A session. The change of rock elastic property to gas saturation can be demonstrated using Gasman fluid substitution equation. We can see from the lower left figure by Ghosh in 2007, from 0 to 5% of gas inclusion, the compressional velocity drops strongly that give rise to the strong amplitude in seismic. Another study conducted by McGregor in 2008 to assess the reflectivity change between 85 and 30% of gas. So from the results, we can see the seismic amplitude can only be differentiated between wet case, which is in blue curve, and gas case in red curve. But between 85% and 30% of gas, the reflectivity change is almost similar, showing the increasing negative reflectivity from 0 to minus 0.1 for both cases. This is the study conducted by Han and Basil in 2002 to explain the difference of rock impedance reduction with the presence of gas in shallow and deep sections. In shallow section, there is a lower pressure and temperature, so the gas trap is likely to have a gas phase behavior with very low gas modulus around 0.00387 gigapascal. So on the left figure, we can see a drastic drop of rock impedance from 0 to 10% of gas. So differently to the deep condition, it has a higher pressure and temperature. So the gas trap is having a liquid phase behavior with higher gas modulus around 0.248 gigapascal. So from the right figure, we can see the reduction of rock impedance with increasing gas saturation. It has a more gentle reduction compared to the shallow section. Cave field is a gas field located in central Luconia and surrounded by 6 other geological provinces, and the gas in this field originated from cycle 1 and cycle 2 source rock, aged around late Oligocene to early Miocene, and the gas migrated through the deep-rooted faults to cycle 5 and cycle 6 sands reservoir, aged from late Miocene to Pliocene. So from the seismic data in cave field, it shows a strong anomalous seismic amplitude in the shallow section due to the presence of thin gas. So this gas thickness is around 23 to 28 meter thickness. And from the petrophysical data, the shallow gas is only made up by 45% of gas saturations. So the CSEM method that's applied in this study is a non-seismic method where it measures the resistivity formation to detect hydrocarbons. So we can see from the top right figure, The resistivity formation is only increased strongly with more than 70% of hydrocarbon saturation. So below 70%, the resistivity increase gradually, with which give rise to the low resistivity contrast and highly will not be detected by CSEM method. So the lower right figure, we can see the illustration of the CSM method where there is a EM transmitter 30 meter above the seabed where all the receivers located to record the signal coming from the subsurface. There are three objectives of this study. The first one is to model the 1D resistivity change with gas saturation variations. The second one to model the 1D CSM response with gas saturation and thickness variations. The third one is to delineate the 2D CSM response of thin sand layers with gas saturation in the K field. These are the data that been utilized, which is a volume of post-tech seismic and 3 wells with basic well log, which are gamma ray, density, neutron porosity, sonic, and resistivity. We also been provided with other petrophysical logs such as water saturation, volume of shale, and effective porosity. So for our 1D modeling studies, the well log from K2 located in southeast has been utilized for our 1D modeling. This is the flowchart of this study. We started with the well log analysis followed by petrophysical evaluation, and after that we divided into two phases. The first one is 1D modeling, which is resistivity and EM modeling. The second phase is 2.5D EM modeling, and from the modeled data we applied the normalized amplitude response analysis introduced by Hessemer in 2010. So he recommends to use a 15% cut-off response to differentiate between economic and non-economic CSM response. So we applied the recommendation to do the analysis for our data. This is the 1D resistivity model that we use to model for gas saturation and gas thickness variations. For gas saturation, two sand layers has been utilized, and for thickness variation, only the second sand layers are used with thickness around 20 meter, and we reduce every 5 meter with minimum thickness around 5 meter and maximum thickness around 25 meter. This is our input for 1D and 2D 2.5D CSM modeling. So from the top right figure, we can see the layout for our 2D 2.5D CSM modeling. There are 9 receivers with the direction from K3 well to K2 well. And from the lower right figure is the cross section of a 2D resistivity model that we use in the modeling. So this is the result of our well log interpretation. There are two sand layers identified, sand 1 and sand 2, with a total thickness around 32 meters. And this is the result of our 1D model resistivity. We can see there is only slight difference of the model resistivity between 100% of water and 5% of gas. And the resistivity is noticeable at 70% of gas and strongly increased at 90% of gas up to 35 ohmmeter. This is the result of 1D CSEM for gas saturation variations. So we can see from the right figure, only 90% and 70% of gas having the response more than the 15% cutoff, where 70% showing the response almost 25% increase, and 90% of gas showing the response almost 230% increase. This is the result for our thickness variations. From the upper graph, for 5% of gas, even with 25% meter, the response is very weak, which is around 2.2% increase. And for 45% of gas, the maximum thickness, which is 25, only show the response increase around 3.3%. So for 70% of gas, only the 25 meter thickness, which is the maximum thickness, having the response more than 15%, which is around 17.5% response increase. And for 90% of gas, all the tested thickness already show very strong response. Even with 5 meter, the response increase is around 35% increase. So this is the result for our 2D CSEM. So we can see the two sense layers can be only delineated by 70 and 90% gas saturations, where 70% of gas showing 40% increase and 90% of gas showing 200% increase. For 5 and 45%, the response is very weak and almost undetectable for all offsets. This is the conclusion for this study. From our model resistivity, the resistivity increased very slightly with less than 1 ohmmeter below 45% of gas. And we start to notice the resistivity increase at 70% of gas, around 4 ohmmeter, and strongly increase up to 35 ohmmeter for 90% of gas. From our 1D model CSEM with gas saturation variations, only 70 and 90% of gas showing more than the cutoff response, with 25% for 70% of gas and 230% increase for 90% of gas. From the thickness variations, only 70% of gas can be detected by minimum 25 meter gas thickness, with 70.5% response increase. At 90% of gas, the response is already above 15% cut off by minimum 5 meter gas thickness. So from the 2D CSEM analysis, we can see only 70 and 90% of gas can be delineated using CSEM method, where 70% of gas show 40% response increase and 90% of gas showing 200% response increase, mainly in the southern part where these sands are identified from K to L. So these are the references for these studies, and I would like to acknowledge all my supervisors, which is late Professor Dr. Devagosh, Dr. Maman, and Dr. Khairul Arifan for supervision contributions. And this study funded by a research grant under cost center 015 LC0224. And I would like to thank Dr. Halim, Head of CSI Center, for providing the facilities to conduct these studies, and to MPM Petronas for providing the data for this study. Thank you everyone for your time, and I open for Q&A session.
Thank you, Fahana. It's a very fine paper to contribute to the late Professor Dr. Devagosh. Okay, you have one, because we can only take one question. We know the importance of the CSEM to detect hydrocarbon. It's been used quite widely in Petronas venture and also other venture worldwide. One question people will always ask is that, can CSEM data be used to investigate deeper targets, given that we have many basinal depression within so-called surrounding K5 in the northern part of northwest Sarawak, and also in the central part of Malay Basin?
Okay, CSCM used to be still in its infancy stage before, and as the time goes by, they are been developing a very powerful electromagnetic transmitter that can travel more deeper section. So as far I know now, they've been developing electromagnetic that they call that can be used for a deep water setting. So, and apart from that, having a very low frequency signal that can penetrate a deeper section, and this electromagnetic source also can transmit a very powerful electromagnetic that can record the signal coming from a very deep section.
Thank you, Fahana, for the question. I think it's good to know about the future availability of this kind of powerful electromagnetic pulse that could unravel the secret of our sub-basin. Thank you very much, Farhana.
You're welcome, Mr. Azhar.
Okay, can we move to the next paper, the paper titled New Approach in Analyzing Rock Property Changes in Vagi Carbonate. The presenter will be Mr. Wan Muhammad Lukman Sazali from Petronas Research Sdn Berhad, supported by Sabriza Salwani, M. Zulhaili, Budi Priyatua, Lydia Kaufin, and Benjamin Yang. Please play the video.
Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all of you. My name is Wan Muhammad Lukman bin Sazali, a researcher from Petronas Research Sdn Berhad, and today I would like to present to you a paper entitled New Approach in Analyzing Porosity Changes in Vagi Carbonates. For today's presentation, I will start with an introduction slide, followed by procedures, result and discussion, conclusion, acknowledgement, and finally, I will end with a Q&A session. X-field is a HPHT or high pressure and high temperature carbonate gas field containing about 70% of CO2 located in offshore Sarawak. As you can see in the figure here, X-field is comprised of three different reservoir layers, namely X3, X2, and X1. Both S3 and X2 are located in the gas-bearing zone, while S1 is located in both gas and water-bearing zones. There is a plan to develop X-field with reinjection of produced CO2 back into reservoir. However, before X-field is deemed feasible for CO2 storage site, a series of laboratory studies must be done. However, as the available X-field carbonate sample are mostly vagi and have higher risk of damage, the team has decided to incorporate digital core analysis or DCA technology into this study. This paper will be focusing on a study of geochemical reaction in the gas-bearing zones of X2 and X1 gas. The study of water-bearing zone as well as other reaction will be discussed later in other papers. Here are the procedures of determining geochemical reaction with the help of DCA. First, the selected sample was scanned under micro CT scan to produce high resolution 3D image. Next, the selected sample was saturated with synthetic brine based on X-field formation water. Next, to mimic the condition of the gas-bearing zone, saturated sample were undergone centrifuge until only irreducible water saturation is left in the sample. Next, the sample were aged in a batch reactor with CO2 at reservoir pressure and temperature. After aging, the samples were scanned once again under micro CT scan to produce post-aging image for DCA analysis. And finally, if we found any damage that is happening in the outside of the core plug, then my team and I will use DCA to extract undamaged middle part for a better representative of geochemical reaction on the samples. Results and discussion. Okay, the figure here is a series of micro-CT image taken from X slice, Y slice, and also Z slice. As you can see here, we were able to produce a high resolution image at 15.6 micron using 1-inch sample. And here is the post-aging micro-CT image that was scanned after the sample was saturated, centrifuged, and aged with CO2. As As you can see here, there are indeed some changes happening before and after the analysis. However, we also found out that there is large-scale changes that are happening in the top section of the X slice, the bottom section of the Y slice, as well as in the Z slice. We have concluded that these large-scale changes is not related to the geochemical reaction between CO2, carbonate sample, and irreducible desaturation. This might be due to the mechanical damage that was happening during centrifuge step. Because mechanical damage does not represent geochemical reaction, we have decided to use DCA to extract the middle part of the image so that we can focus on the porosity changes that are caused by geochemical reaction of CO2 carbonate sample and also brine in the irreducible water saturation. As you can see here, with the help of DCA, we managed to extract a subset for our porosity changes study. In here, we were able to determine the porosity changes due to dissolution, which represented by the black dot, as well as porosity changes due to the precipitation, represented by these white dots. And here is the result summary for plug A and plug B, which are the plugs taken from X2 and X1 gas. For comparison purposes, we are showing both porosity changes, which include mechanical damage and also without mechanical damage. If we include mechanical damage, the porosity changes is quite high, which is about 1.7 porosity unit percent in plug A of X2 zone and about 1.1% for the X1 gas zone. However, with the help of DCA and extraction of the middle part without mechanical damage, the actual porosity change due to geochemical reaction is much less, which is about 0.009% in X2 and 0.006% porosity unit in X1 gas. In conclusion, due to the fragility of the selected sample, there are some mechanical damage to the core sample that are not related to the geochemical reaction. If we include this mechanical damage, it will not be representative of the geochemical changes that will happen during CO2 storage in the field later. Thanks to the CA, we were able to extract the middle part that were not mechanical damage and study the porosity changes that is happening due to geochemical reaction. Based on the result, we found out that the porosity changes is indeed very minimal and in lab scale does not have major impact during CO2 storage in fixed feed. The lab result will be handed to the modeling team to simulate the changes in porosity due to chemical reaction in the field scale. In conclusion, DCA has proven to be a very useful method in determining porosity changes in reservoir rock because not only it able to determine porosity and porosity change in the plug, but also can extract the middle part for more accurate analysis. And this is the end of my presentation. I would like to acknowledge my co-authors, Sarisa Salwani, Dr. Zohedi, and Dr. Tim from the RSP, as well as Dr. Lydia Westring and Benjamin Yang from Australian University for their contribution in the completion of this paper. I also would like to thank Petronas for granting permission to publish this information pertaining to this paper, as well as to the technicians of PRSP, Thermovision Scientific, and AMU. And this is the end of my presentation, and I welcome question from the floor. Thank you.
Okay, thank you very much, Mr. Wan Muhammad Lukman. An interesting look at so-called analysis of the core plug.
Yes.
Seldom we find core plug nowadays been done. So the information that we can extract from the existing core plug is very important. Okay, there's one question to you with regards to the effectiveness of the DCA analysis result. Are you able to establish so-called a database of the DCA analysis result in the central part of the broken core plugs?
Okay, thank you for the question. Actually, yes, we are able to come up with porosity changes in the broken part as well as the unbroken part, because in the image processing software, uh, we can do calculation digital core analysis on the whole core plug as well as the segmented part. So if we selecting the middle part which is undamaged, we can do calculation on that. But when we selecting the middle part of the undamaged part, we can also do calculation on the damaged part, which is the rest of the uh, core plug, which is due to the mechanical damage and not due to the geochemical reaction. Yeah. Yes, we can do that, and we already did that actually.
Okay.
Yeah.
So indirectly, how do you see that the understanding on the central part of the broken core plug that add additional more information to understanding on the high CO2 field?
All right.
Do you think that the additional information that we get from this so-called broken plug in the central part could assist in changing indirectly the saturation of the understanding on the saturation of the CO2 of a field?
Yes, I'm glad you asked that question. As I mentioned in the beginning of my presentation, the project itself is separated into two parts. The first one is the core plug taken from the water saturation zone or water zone. And this presentation is focusing on the core plug that is in the gas zone. So what we are going to do, what we are studying is to compare what is the reaction of CO2 to the core sample that are originally from the water zone as well as from the gas zone. So what we can see here when we do the analysis in the water zone, the porosity changes due to CO2, brine, and rock reaction is about 1%, which is equivalent to the porosity changes with the mechanical damage. So when we do this comparison, it does not show any difference between water and gas zone. It's only when we do the subset, which is in the middle part of the gas uh, zone sample, which are broken due to mechanical damage, then we found out that the geochemical reaction is actually much lower, which uh, uh, which is proven our hypothesis, which is the reaction between CO2, water, and also rock will be much severe in the water zone compared to in the gas zone.
Okay.
Yeah.
One last question
All
with
right.
regard to push the boundary of so-called the DCA.
Okay.
It's an expensive tool.
Yes.
Do you think could we use this digital core analysis
Mhm.
to investigate the porosity from the cuttings coming out from the drilling itself?
Okay. The porosity of cutting, yes, we can do. Okay, basically, when we do micro CT scan or digital core analysis, what we are analyzing is actually the image of the sample that we are taken of. So yes, we can do the scanning as well as digital core analysis on the cuttings, but to say that the porosity represent the uh, the section or the core plug will depends on the sample itself. For example, if the section or the core plug is homogeneous, then the porosity of the small cuttings will represent the plug. But if the plug itself is not homogeneous, it's very heterogeneous, then the porosity of the just a small sample of the drill cutting, it will not represent the core plug porosity or maybe the sections porosity. So it will depends on the lithology of the field and the rock itself. Yeah.
So thank you very much, Wan Muhammad Lukman.
All right.
Fine discussion on the subject. Thank you very much. I wish you all the best. Stay safe.
Right. Thank you.
Okay, we will go to the last paper by Miss Al Fatima, entitled Distinction Dynamic Provinces Implication on Sandstone Reservoir Characterization. This is by Al Fatima, Miss Al Fatima, supported by Dr. Numair Ahmed Siddiq. Please play the video.
Good morning. I'm Al Fatima, Research Scholar, Department of Geology from Periyar University, Salem, India. My topic is Distinction of Dynamic Provenances through Integrated Geochemical Proxies, Implications on Sandstone Reservoir and Characterization. Geochemistry of the recent ancient clastic sediments or rocks plays an important role in interpreting the depositional setting, provenance, depositional environment, climate, and composition of rocks in the source areas. The Mesozoic era hosts one of the eventful phases of the Earth's history, among which the Cretaceous period was affected by prolonged greenhouse effect, which led to the alterations in seawater temperature and eventually to the retreat or advance of glaciers causing high-frequency sea level cycles that in turn influenced the depositional sequences of the Kaveri Basin. The documentation of Gilbert-type deltaic system during Santonian Campanian, that is sandwiched between predominantly calcareous and or argillaceous deposits of the Kaveri Basin, and fascist transients from the fluvio-marine signature. This is the regional setting. You can see here, this is our study area. The Kaveri Basin is located in the southernmost part of peninsular India. It is originated as a rift basin during late Jurassic early Cretaceous with the northeast-southwest trend and continued to evolve until the end of Tertiary through the rift and associated structural movements. The Silakuri Formation, which is comprised of three lithostratigraphic members: the Varakupai lithoclastic conglomerate member, Sadurbhavam pebbly sandstone member, and Varanavasi sandstone member. There are two lithosections, and compared the geochemical profiles of both. The major oxide concentration of both lithosections were normalized against UCC. The first figure is that. And after that, plotted log Fe2O3 versus K2O with log SiO2 versus Al2O3 discriminant diagram. The plot of studied samples in the shale, Arkose, sublithoranite, and Fe shale is according to the textural maturity of the rocks based on their geochemical composition. The second one, that figure is the rare earth elemental trends of both the lithosections, and they have similar trends showing high HREs and flat LREs with positive and negative EU anomalies. These are the geochemical profiles of both sections that were plotted stratigraphically according to construct geochemical profiles and to infer depositional and diagenetic processes and other events on the temporal scale. Curves were drawn for absolute concentration, linear and polynomial trends. Among the profiles, the general decrease of silicon, strontium, Fe and Na, increase of calcium, barium and K are easily discernible and may indicate the transition from the occurrences of texturally and mineralogically immature sediments at the bottom to mature sediments at the top. The inverse relationship between calcium and associated sediments and silica and associated sediments could be explained by gradual change in the depositional condition from fluvial-driven sediments of the Varakupai member and fluvio-marine deposition of the Sadurbaga member to the exclusively marine Varnavasi member. Through the entire stratigraphic record of the Sillakudi formation has an extreme overwhelming of BA with a few recognizable peaks. If an influx of BA orthoclase is considered as the reason for this peak, significant exhumation of the provenance and influx due to heightened fluvial flow need to be surmised. Weathering. These are the weathering plotted figures. The CIA values can be also plotted in ternary diagrams such as the first one is ACNK and second is ACNK F1. ACNK ternary diagram of the studied samples. The plot shows all the samples except some of the litharinates are above the feldspar joint. The trend samples is more or less parallel to the ACN joint. The immature nature of litharinates also shows granitic composition too, while most of the samples show affinity to an intermediate composition. While in the ACNK FM diagram, most samples are moderately weathered and show affinity to the felsic to intermediate source composition. Sorting and recycling. Scatter plot of THSC versus ZRSC. It shows plotting of all the samples except few litharinates and thus source-dependent variational trend. Then the ZRSC ratios except few litharinates in the Varakupai member. These signify sediment reworking in the lower part and the absence of noticeable recycling in the upper part of the Sillakudi formation. And the second figure is ICV versus CIA. It depicts weak weathering and an immature nature of sandstone, except the arkose. Provenance. In this diagram, it depicts four major provenance fields like felsic, mafic, intermediate igneous provenance, and quartzo sedimentary provenance. All the members of this formation in this field, in the field of quartzo sedimentary provenance, it indicates some degree of reworking of older sediments, rocks from the Santonian Campanian, a factor that may suggest restricted source area and lack of chemical weathering in the source area, or both. The LATH versus HF, wherein the samples fall in the field of acidic arc and mixed fields. The lesser concentration of hafnium suggested fresh sediment influx rather than recycled nature of sediment samples. The paleotectonics, that is K2O versus Na2O versus SiO2 diagram. It determining the tectonic setting of the studied samples. Majority of the samples are in the passive margin according to this diagram. Few of them are shifted towards the active margin because of their low K2O versus Na2O ratios and high SiO2 values. The transition of tectonic setting from an active to passive margin might have influenced the distinct sediment geochemical characteristics of the stratigraphy members as well. Here is the conclusion. The facies and geochemical trends of the Sillakudi formation suggested physical energy dominated erosion, transport and deposition during the Varakupai member, which is the lower part, and which was followed by gradual submergence of the confluence to finally culminate at the broad stable marine shelf. Accordingly, an increase in weathering in the source area coeval with a diminution of tectonic influence, an increase of sea level, a transformation of onland fluvial depositional setting to intertidal estuarine open marine, many of which were probably enforced by climatic reversals, have produced the observed major trace and REE composition, positive and negative EU anomalies, and scatters the geochemical discriminant plots of provenance, weathering, and tectonic setting. Prevalence of multiple tributary channels that drained varied lithologies of the source areas and were actively eroding transporting materials to the depositional sites have also been yet unequivocally established. Domination of varied tectonic climatic relative sea level conditions in the source area and depositional sites have produced distinct geochemical signatures stratigraphically. Results of present study emphasize that while the scatters of samples points in discrimination diagrams might normally be interpreted as representatives of various tectonic setting, provenance, and weathering regimes, they should also be interpreted as the indications of transformation or transience of source area depositional setting from active to passive exhumation of different parts of the source areas, and are also changes in the rates of weathering of various lithologies and commensurate sediment influx into the depositors. Thank you.
Thank you. Thank you, Miss Fatima. This is an international paper on geology in India on Cauvery Basin. Okay, there's two questions to your paper. One is that how much have this study in terms of the geochemistry of the what we call it the geochemistry based on the elemental chemistry analysis influence the geological model that currently been adopted in the fluvial system in Cauvery Basin, mostly from the Upper Cretaceous period? Hello, Miss Fatima? Are you able to join us? Oh, let's just wait for a couple of minutes. We have 3 minutes to get back Miss Fatima online. In case we are unable to get Miss Fatima, you can send any question that you have to Miss Fatima through her email that you can get from the program book. So let's just give a couple of minutes. Okay, while waiting for that, we will play the sponsor video that have assist in making this Icer 2020 a reality. Please, Ms. Huda.
Assalamu alaikum and hi everyone. I'm Dr. Firasad Abdul Karim, a postdoctoral researcher in the Shell Gas Research Group. Upon completion of my PhD from Chemical Engineering UTP, I joined Shell Gas Research Group since 2018, working on CO2 and CH4 absorption and desorption on Shell. studying the enhanced gas recovery opportunities. Very grateful for all the facilities and equipment that we have and allow us to initiate and develop very novel and innovative research. Thank you.
Hi, I'm Nadia, a research scientist at Shale Gas Research Group for almost 2 years now, and I'm currently working on shale gas characterization involving modeling and predictions. It's been quite an enjoyable role working at SGRG as we have a very diversified team of researchers from engineering, applied mathematics, and also geosciences.
My research activities is on mainly gas hydrates and enhanced oil recovery. So under this MOU between our institute and this UTP Petronas, we have visited here and we are delighted with the research facilities of this UTP, particularly this R&D section.
And I'm working there on mainly the unconventional reservoir resources, that is CBM and shale gas. In addition to that, the fracturing of different reservoirs. Come here to University Technology Petronas for some collaborative research, and for that I am very much thankful to our administrative and also Professor Icer. So here we have discussed actually for different collaborative research. We have explored different areas where we can work hand on hand together and can explore more and more hydrocarbon energy from the different resources.
I was a research attachment program student in Institute of Hydrocarbon Recovery, University of Technology Petronas. And surely I feel UTP will be a global leader when it comes to research in hydrocarbon recovery or petroleum industry, because it has international grants and extensive research facilities with very enthusiastic researchers. And it has a world ranking of 50 under 50 by QS Asia World University. So I think with having all these facilities, and it will be one of the best in the coming years. Thank you, Malaysia, UTP, Institute of Hydrocarbon Recovery, for giving me this exposure, giving me this responsibility of contributing to this industry and creating an impact.
My attachment here at Institute of Hydrocarbon Recovery is for 8 months, and my projects revolve around unconventional resources, mainly shale. My research attachment here at IHR has actually opened my mind up about the career options available, especially in the research and development sector within the oil and gas industry. IHR has the reputation of being a very quality research institute in Malaysia. So the state-of-the-art facilities that are available here has enabled me to carry out various experiments and analysis. So the technologies that is used here is actually going to give me an edge when I graduate and move on into the oil and gas industry in the future. Throughout my internship period here, I was given the opportunity to work directly under Dr. Icer, and he has provided me with constant guidance and directed me in a way of how to carry out a proper research. And through that, I've managed to become a co-author of a chapter in a book and also write my own conference paper, which I'll be presenting at a conference next month.
This system can run up to 80 degrees centigrade and almost 150 bar, which is equivalent to 15 megapascal. This is the main parts we have in the system, where our 2 canisters of absorption system we have, where we can load 2 separate powder samples or even small core samples of shell. And here we have the flooding part where we can load one almost like 12-inch of core of shell, almost 30 centimeter or slightly less. And here are the heating system that we have, the fan to distribute the heat at 80 degrees. The DSA 100 to measure the contact angle, superficial tensions, and some of the other physical properties of the shell material, and some also other porous materials that we have. In this equipment, we can go up to different temperatures, up 60 or 80 degrees, and also very high pressures, such as 300 bar, 30 megapascal, or even more, slightly. Which is a very unique equipment, and we can find it as iconic in some of the physical properties of shell and porous material all over the world. In this equipment, actually, we have some types of shell material that we can study two types of measurements. Whether studying the contact angle and wettability of the shell, like if we say that this is the type of shell that we need to utilize, which need to be polished and very flat surface. Then we can drop the fracking fluids, dry, in kind of, or even crude oil, or any type of emulsion that we are limiting or predicting depending on the reservoir conditions. And the reservoir environment, which can be in the room of the sample surface, which can be any kind of gas, such as CO2, methane, nitrogen, helium, or even some liquid hydrocarbons.
Okay, here we go. We come to the close to the afternoon session. On behalf of the Icer 2020 from the Geoscience Department, we would like to thank the audience for the patience to go and listen to the 6 fine presentation from local and also international paper. If you have any question, I would recommend you to contact the presenters directly via email, and their email are available in the forum, so-called the program book. With that, without further ado, I would like to let go this section. Thank you very much again. Stay safe, and may you be blessed moving forward. Thank you very much.